Hi, today I'd like to show you some of my results that I have achieved using chemistry in several years. So, I found my passion for chemistry 4 years ago, when I was in the middle school. It was due to a very simple experiment, and the only substances I needed were potassium permanganate and hydrogen peroxide. I made a video where I explained this experiment, so you should check it out. After having the experiment done, I thought that I was a kind of god who is able to create or to maneuver with some non-living objects in order to have a result. This first experiment determined me to choose the path of chemistry or involving it so that I could create something helpful for humanity. I found that growing crystals makes me feel like a creator because I was making something evolve from a salt, metal or non-metal. In 2 years, I made a big enough collection of crystals that I would like to present you. First, we need to choose the material of which we will grow the crystal. Essentially, practically any substance is suitable for the crystal growth. For example, protein crystals, crystals of iodine, metal crystals. Even air can be turned into a crystal when it is cooled to a certain temperature. For normal conditions, the best suited are inorganic salts. All these substances can be bought in a chemical store or via the internet. The crystal shape is defined by the crystal lattice of a substance, starting with my bismuth crystals. In my opinion, these are the most beautiful ones. Bismuth is a heavy metal and in the periodic table of chemical elements is located next to the lead. It is a shiny and a very brittle metal. Bismuth's melting point is 271 degrees Celsius, so it can even be melted on a hot plate. And unlike lead, bismuth is not toxic. Bismuth's surprising property is that it starts to form beautiful crystals during solidification. The size and shape of the crystals will be dependent on the solidification rate, as well as the presence of impurities. The slower the cooling, the higher and more beautiful crystals will be obtained. The crystals I have obtained are not very big, however, with a beautiful oxide film. These are just good looking, but they have no practical use. However, I make necklaces from them and then sell them like this one. I also have obtained some kind of an improvised post-apocalyptic town from the formed crystals. Crystallohydrates are being made by pouring hot water into the vessel and adding salt until it will be no longer dissolvable. In this case, we get a saturated solution. Different salts have their own solubility curves. Solubility curve is a measure of how many grams of the salt can be dissolved in a 100 milliliters of water at a certain temperature. Also, for all the salts, the information is different. Once we have prepared our saturated salt solution, it has to be filtered while it is still hot. Filtering is not required. However, if you buy the chemicals in a garden shop, not in a special shop, the solution must be thoroughly cleaned from possible impurities. I would still recommend to initially use pure chemicals. After the filtration, the glass is left for a few days to let the crystals form. Crystals form as a result of the change in solubility of salts in the water when the temperature changes. Excess crystals, which cannot be dissolved in the solution, fall to the bottom of the cup. Next, the most beautiful and large crystal from the mass of crystals that were formed on the bottom of the cup, or one that is easiest to tie on the thread, is chosen. I could also advise here to use a thin fishing line instead of threads. Growing crystals requires a lot of time and patience. If you want to get a very smooth and a beautiful single crystal, you'll need to filter the solution every 2 weeks to maintain its cleanliness. If the solution is dirty, a crooked crystal will grow and you'll get polycrystal instead of that single crystal we want. Polycrystal is when a lot of crystals fuse together. The formation of crystallohydrates occurs because the water from the solution will gradually evaporate, thereby increasing the concentration of the solution. Since we have a solubility curve, we can learn that the excess material that cannot be dissolved must go somewhere, and this is the substance that forms our single crystal. The second in my collection are the red blood salt crystals. You can call it red blood salt or potassium hexacyanoferrate 3. Red blood salt creates beautiful polycrystals. Also, this substance is completely safe and non-toxic. It is desirable when growing the crystals to store the solution container in a closet or in any other confined space. It is necessary to prevent dust from entering the solution, as the impurities can make the final crystal not clear or to grow with a different geometrical shape like in my crystals. However, the smaller ones have a better shape than the big ones. In the end, to make sure the crystals are stored in a better way, they can be covered with a clear nail polish. For every crystallohydrate, I have made an origami shape that represents how the geometrical form of the crystal should be. I also make comparisons between my crystal and between the shapes. For the hexacyanoferrate 3 is the tetragonal system, dipyramidal class, and the form of a dipyramid or a prism. Next are the double alum crystals, or the potassium and aluminum alum with potassium chromium alum. Also, in single crystals growing, it is important to avoid extremes of temperature and pollution of the solution. I covered the crystal with colorless nail polish. 1 or 2 layers is usually enough. It is important to protect the crystal from further destruction. After the nail polish has been dried out, it is okay to take the crystals with bare hands. However, I would not prefer to. I raised 2 purple crystals. The alum has the isometric system and hex-octahedral class with octahedron forms. I also have obtained some polycrystals from this solution, and they are beautiful as well. However, they have been exposed to air and lost some of their beauty. The bonus one should be the crystal from potassium and aluminum alum, without the potassium and chromium alum. I thought it would look nice if I had a transparent octahedron. It, as well as the others, have similarities with the correct shape. However, it has some additional crystals growing on it. In the test tube, I have some small alum crystals. Next on the list are the copper sulfate pentahydrate crystals. I have 2 of them. One is grown from the substance that I have purchased in a garden shop, and other from a salt obtained by electrolysis of the sulfuric acid with copper electrodes. These 2 were my first crystals to grow, and they are not fully transparent, having some defects in their shape too. They have monoclinic system with the prismatic class and front and side pinacoids forms. These 3 are made from Morse salt. Morse salt is a double salt of iron ammonium sulfate. To prepare Morse salt, we need iron sulfate and ammonium sulfate. The ideal crystal shape should be symmetrical and have a complex prism. As can be seen, the shape of my crystal is prismatic but with some defect. We can see that some faces have irregularities and flaws. Also, the crystal is not fully transparent. All this testifies to the defects in the crystal. The defects in the crystal are due to the temperature fluctuations during the growth, the presence of dust in the solution, and the resulting iron oxide contamination. I have 2 more crystals, and as it can be seen, one is more transparent and the other has a completely different form. The more transparent one was one of my experiments. As you can see, it has a rounded edge. As it was initially thought, you cannot change the shape of a crystal that is determined by its crystal lattice. However, I have achieved a modification of its shape by not letting the crystal a physical space where it can grow. It grew near a wall of the container, so that I forced the crystal to evolve in a condition of pressure. The other one had grown into a container that wasn't stored properly. Some of the iron 2 sulfate has turned into iron 3 sulfate with a completely different crystal lattice, so in the solution were 3 different substances. These ones are crystals made from nickel and potassium double sulfate. Now, the lab gloves are essential because the nickel salts are very toxic, even covered with nail polish. I have grown 2 single crystals and some polycrystals, and I think they could easily be a part of a table decor. Because of the temperature fluctuations, one of my single crystals have dissolved and then exposed to air. Surprisingly enough, they have a significant use, as these crystals are being used for detecting infrared light, which cannot be observed with bare eyes. Next are my 2 citric acid crystals. The first thing you should notice is the fact that one is white and another is yellowish. The proper crystal should be transparent and have a form of a rhombodecahedron, although the yellowish crystal has such color due to the fact that after growing it was not stored properly but placed near an unsealed ampule of iodine. After time, the iodine was sublimating, and a part of the iodine vapor deposited on the walls of the crystal. However, its shape didn't change and is similar to the real geometrical shape of the crystal. The other one was contaminated with the Turnbull's blue precipitate, so I had to wash the precipitate from the crystal. The water not only removed the precipitate but also had dissolved some parts of the crystal, leaving some holes in it. Also, in some parts, the crystal have a bluish color left from the Turnbull's blue reactive. Moving on, these ones are tiny little single and polycrystals made from the magnesium and potassium double sulfate. I have not managed to grow a big single crystal yet, however it is still growing. These crystals should have a basal pinacoid form or the form of a prism. In comparison to my origami shape, it is hard to observe a regular single crystal, however there are some. These were grown from potassium dichromate salt. To grow a big enough crystal was a heart of a deal, so I have only small poly and single crystals. The orange-reddish color of the substance is due to the dichromate ions. These crystals should have the same form, system and class as the potassium hexacyanothreate 3 crystals. For comparison, I show them both at the same time. I would like to mention these crystals are especially dangerous for the skin because the potassium dichromate is cancerogenic. This is why I have stored them into an ampule made by myself. I created it from a test tube. In this sealed test tube, I have stored copper metal crystals. They are quite reactive with the air moisture and the oxygen gas, so I keep them in sulfuric acid. That prevents the formation of the copper 2 oxide. You can probably see that there is something besides the copper metal, something blue. Well, that is copper sulfate. Interestingly enough, the copper reacted with the sulfuric acid and the oxygen gas that was in the tube and formed copper sulfate. The formed solution was supersaturated, so it precipitated out some copper sulfate crystals. In the test tube, you can see the pure copper powder as well as some large crystals of the metal. The last in my collection are my crystals of iodine. I have obtained them by sublimating the iodine into iodine vapors, and when it touched a cold wall, it deposited nice and shiny crystals. The iodine has the property of sublimating, which makes it easier to disappear, leaving only the iodine smell beside. I also keep it in an ampule, after that incident with the citric acid crystal. Some crystals broke into smaller pieces due to the bad transportation. However, I have there some big crystals too. There is actually a portion of melted iodine that have been freezed on the wall of the ampule. Crystal growing is very exciting activity that develops patience and mind. I am sure that if I continue with growing crystals from different substances, I will end up growing artificial diamonds for different purposes. I am certain of that. Besides my collection, I'd like to present you these two knives with some inscriptions on them. I have managed to learn how one could engrave an inscription on a piece of metal using electrolysis. As the power source, I use my transformer, which converts 220 volts from the power socket to 10 AC current volts, then transformed into direct current by these two bridge rectifiers. The bridge rectifiers are attached to a cooler because they are easily warming up. At the end of the cables, there are a pair of alligator clips for car batteries. The transformer was taken from a microwave and then modified by my teacher of physics and me. He tested it for safety and helped me with the practical part. Here, I show it on practice how I'm making copper sulfate using electrochemical method. The current is approximately equal to 16 amps. I also have another transformer that converts 220 volts into no more than 1 volt, but the current is very high, and it can melt down aluminum very easy. I use it for contact welding of two pieces of metal. Also, if I was good at drawing, I think I would make some piece of art on some sheets of metal using the electrolysis. So you see, that's why I'm working with gloves, because if I was not, it was a terrible and a disaster for my hands. So thank you guys for watching and have a great day. Bye.